double angle, half angle. Okay. So review from last time, the double angle give it last time. Yeah. So the formulas for double angle is given like this. First one, the sine function. So number one, the sine of 2x equal 2 sine of x cosine x. Number two, the cosine of 2x equal cosine square x minus sine x square x. And also this is equal 2 cosine square of the angle x minus 1, and also equal 1 minus 2 sine square of x. Third one is the tan of a double angle to x is equal to tan x over 1 minus tan square of the angle x. So this is for the double angle. So today we're going over the half of angle, but before we're going over the half of angle, I'm going to give you the formula for lower formulas. So they are given like this. So these formulas are derivative from the second one, from the cosine to x. So we have to know first one, the sine square of x. I mean this one is equal 1 minus cosine 2x cosine of 2x over 2. Number two, the cosine square of x is equal 1 minus 1 plus cosine 2x over 2, and 3, the tan square of x is equal sine over cosine, sine of square of x over cosine square of x. So this is mean this over this one, they give me 1 minus cosine of 2x over 1 plus cosine of 2x. So this formula is calling the lowering power, because from square goes lower power of 2. The exponent here is 2, the exponent here is 1. Okay, so these formulas are derivative from here, from cosine, from the second one. Now we're going over the half angle. So I'm going to put the half angle also the same paper here. So I'm going to put here half angle So first one is the sine. Okay, number one, sine of the half angle, like u over 2. The formula is plus negative. So plus negative is depending on the quadrant. If it's the sine in the first quadrant, second quadrant, sine will be positive. Third and fourth will be negative. Of square root of 1 minus cosine of the angle u over 2. How I found it is derivative from here. So I plug instead of x, u over 2. So I plug here u over 2. The 2 with the 2, they cancel. And then I take the square root for both sides. Take the square root for both sides, I get plus negative. 1 plus this. So this is derivative from the first one. Second one is the cosine of u over 2. This is equal, again, positive, negative, square root of 1 plus cosine of u over 2. Third one is the tan of the half angle u over 2 is equal 1 over cosine 1 minus cosine of u over sine of u, or this is equal sine of u over 1 plus cosine of u. All this formulas, it's for, you cannot use it in the exam, just you have to memorize it. Okay? You have to memorize all these formulas for the exam. Okay, let me give you example how we can use the half angle. Last time I gave you example for the double angles. So now we're going over the half of angles, but I talk about the formula for lower power because I'm going to derivative the formulas for half angles from this. So the example is, by using the half angle, formulas, find sine of 22 and a half degree. How can I use the half angle formulas, this, to find the value for sine of 22.5? Any idea? So now we can find the value for sine of 22.5. How can we find it? By using this things. Yeah, I'm going to use the formulas. Which formula?
The sine u over 2 formula.
Okay, it's sine of u over 2 formula. But okay, so I'm going to use the sine of u2 over 2 formula, but how we can use it here? Here we don't have over 2.
So in this case, u would be 45. U over 2 is 22 and a half, right?
Exactly. So here, this is, thanks William, so this is equal sine of 45 over 2. 45 over 2 is 22.5. Now go back to sine u over 2 formulas. So this is equal, by using the formula, positive negatives. So I will put positive negatives. Square root of 1 minus cosine of u. U is 45. So 1 minus cosine of u. This is u. Over 2. But here we cannot use the 2 sign. So you have to choose positive or negative. But because the 45 is in the first quadrant, so the sign will be positive. Exactly, Martin. So here the sign will be only positive. Now let's solve these things. So I get 1 minus cosine. Cosine of 45 is, here I get, what is the cosine of 45? So 1 minus
Root 2 over 2.
root of square root over 2. Yes. Everything over 2. So to simplify it more, like to simplify these things more, so the best things is to multiply everything here by 2 and multiply here everything by 2. So multiplying the numerator by 2, multiplying the denominator by 2. So actual like multiplying by 1, because 2 over 2 is 1. So now I get 2 times 1, 1 times 2 is 2, minus square root of 2 over 2 times 2 is square root of 2, over 2 times 2 is 4. Now the square root I can distribute it to the numerator and denominator. So I can get square root of 2 minus square root of 2 over square root of 4. Square root of 4 is equal 2, so I get now 1/2, because it's 1 over square root of 4, so 1/2 times square root of 2 minus square root of 2. And this is the answer for sine 22.5. So now I can find the values for the 22.5 by using the formula, or any like values by using the half formula. And because I know the value for cosine of 45, so I can find the answer for this. This is the only example we need for the half angle. Any question? Any question? Just use the formula and plug it direct. Okay, so now let's go over 7.4 is the basic trigonometric equation. So 7.4 basic. Before I start this section, I'm going to give you some review, because this review will help me to find the values during this section. So first of all, if I have angle reference, here the angle in this first quadrant, angle in the second quadrant, angle in the third quadrant, angle in the fourth quadrant. So we have to know the angle in the first quadrant, pi over 3, and 2 pi over 3, it's in the second quadrant, and 3 pi over 3, it's in the third quadrant, and not 3, sorry, here 4 pi over 3, and here we have 5 pi over 3. All these angles, they have the same reference number, is pi over 3. All of this have the same reference numbers. This one is in the first quadrant, second quadrant, third quadrant, fourth quadrant. All of these have the same reference. Pi over 4, first quadrant, 3 pi over 4, second quadrant, 5 pi over 4, third quadrant, 7 pi over 4, fourth quadrant, have the same reference as pi over 4. And pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. All of these angles have the same reference as pi over 6. Any question for this? Clear? And also have to know the periodic function. Here, function, and the period here, and here one complete period. Period. So the function is sine, cosine, and tan. The period for sine is 2 pi. Like every 2 pi, their values are repeating they are repeated. The cosine is 2 pi. For the tan function is pi. Every pi, the values are repeated. One complete period is from 0 to 2 pi. Now cosine the same things, from 0 to 2 pi. But for the tan is from minus pi over 2 to pi over 2. This is the one complete period. This also table, we're going to use it during this section. It's very important. Also, the last things is very important to know is the sine. What does that mean for the sine? I mean, like if I have fourth quadrant, all function here, all function are positive. All student take calculus. So all the function is positive here. The sine function is positive here. The tan only positive. The cosine is only positive here. This is just only review. I think this is also review. Now, by using these tables, we can solve an example. So example number 1, solve the equation sine of theta equal 1/2. So the question is sine of theta equal 1/2. The mean of solve the equation, find the value for theta. So the first step, you look into the theta. You see here theta, sine of theta equal 1/2 is positive. Positive means the quadrant. So the sine is positive, mean theta will be on which quadrant? Which quadrant the sine is positive?
1 and 2.
1 and 2 only. 3 not, no. 4 no. So the theta will be on first quadrant and in the second quadrant only, because the sine is positive. This means the quadrant. Second things you have to ask yourself, what is the theta reference? What the angle reference if I plug it here inside the sine, they give me 1/2.
5 or 6.
Pi over 6. So the angle is, the reference is pi over 6, because sine of pi over 6, by using the table from previous section, sine of pi over 6 is 1/2. So the theta reference here I can set is pi over 6. So this is first step, second step. So theta reference is pi over 6. Go back to the table. Theta reference is pi over 6. Which angle of the reference pi over 6? It's in the first quadrant. So this one, and in the second quadrant, and this one. So I'm going to pick this angle and this angle. So theta will be in the first quadrant and second quadrant. So theta 1 equal pi over 6. I don't like to use 1 here. So theta will be pi over 6. And theta will be 5 pi over 6. How we know? From the table. Pi over 6 and 5 pi over 6. So the first step, you have to find the sine. You know where is the position. Second step, you ask yourself which value, which reference, if I plug it here, they give me 1/2. So it's pi over 6. You go to the table, you find the values, the theta in the first quadrant and then the second quadrant. So third step is to find the solution in general. So find whole solution. Because this function is periodic, so I have added the period for the sine. So the theta will be pi over 6 plus the period. The period over the sine is 2 pi. I have to add 2 pi times k. K is integer number. Would be like 0, 1, 2, 3, 4, 5, 6, or negative. -1, -2, -3. So all these angles, if I plug it inside the sine, they will give me always 1/2 positive. And the second angle is 5 pi over 6 plus 2 pi k. Any question? So it's both. What does that mean? Yeah, the both. The both is the solution. Theta equal pi over 6 plus 2 pi k, and theta equal 5 pi over 6 plus 2 pi k. The both are the answer for this equation. So again, step by step, sine, reference, or solution. Any question is fine here. So here I can set add. Another example. Solve the equation cosine of theta equal negative square root of 2 over 2. So step by step, first step, the sign. This sign means the quadrant. This means the angle here in which quadrant. The sign is negative. The cosine would be negative since the sine is negative.
It's quadrant 2, 2 and 3.
So theta will be on first quadrant, and no, not in the first quadrant. First quadrant will not be positive. Like
It's 2 and 3, right?
2 and 3, yes, exactly. Like, well, he said 2 and 3. This is true. Because in 2, the cosine will be negative, and the cosine will be negative here. So theta will be on the second and on the third. Now, second step, find the reference. This first step. Second step, the reference. So what you're doing, like you're doing like this. You hide the sign. You hide the sign, and you ask yourself, which angle reference, if I plug it here, they give me square root of 2 over 2. Which angle, if I plug it here, they give me square root of 2 over 2. What's the angle? If I plug it here, they give me square root of 2 over 2.
Over 4.
Pi over 4. So the cosine of pi over 4 is square root of 2 over 2. Now you remove this one. Now we get the sine. Now you ask yourself, what is the angle? So this is the reference. You go back to the table, you check for the second quadrant and third quadrant. The reference for the second quadrant, this one, and fourth, this second and third. So would be like 3 pi over 4 and 5 pi over 4. Angle, he said, but if we are working with cosine, why did you use sine? I didn't use sine here. No, I mean like sine is not a sine function. Sine positive or negative. Sine here is different about sine. Sine here is mean positive, negative. Sine function. Okay. So the sine is negative. The theta will be in the second and third. So theta, go back to the table. 3 pi over 4 and 5 pi over 4. So theta is equal 3 pi over 4 and 5 pi over 4. So this is my solution. Now, to find it in general, number 3, for all solutions, first one equal 3 pi over 4 plus 2 pi k and theta equal 5 pi over 4 plus the period. What is the period for the cosine? It is here, 2 pi. 2 pi k. The pi over 4 is, no, here, look, Angel, this is the reference. The reference is different about the angle. The reference, what value if I plug it here? First step, you put, like I said, you hide the negative, like this. You find the reference. I'm not going to use the reference. The angle, I'm using the angle because by the reference, I can find the second and third quadrant for the angle. Understand what I did? I did not use the reference. I used the reference just to check what is the angle in the second and third quadrant. So this is the solution. Okay. Last example in this section. Example.
Wait, I'm sorry, Professor. Just really quick.
Yes.
The last thing you wrote was what, plus 2 pi k? Can you just go over that really quick? What's the k in this case?
Okay. So I mean like this. I know the function is periodic. I mean for periodic, like every 2 pi they are repeating their values.
Oh, I see. And k in this case is the same as the standard. Okay, that's just the interval. Thank you.
So this is, oh, okay. The k here is integer numbers. So I said here k.
Okay.
K is integer. K belongs to the integer numbers. Like 0. If I plug the 0, they give me 3 pi over 4. If I plug 1, they give me 3 pi over 4 plus 2 pi. If I plug 2, 3 pi over 4 plus 2 pi times 2 is 4 pi. And this value, if I plug inside the cosine, they will give me negative square root of 2 over 2.
Okay, thank you. That makes sense.
Okay, the same things here for k. K is integer numbers. The integer numbers, let me remind you, is all negatives, -2, -1, 0, 1, 2, and dot dot dot. This is integer numbers. Okay. Question: solve 2 sine theta minus 1 equals 0. So the same steps like before, but here like we have to solve it after we if we solve it, make sine equal something. And after that, we're going to use the same step like here. So to solve this one, I have to add 1 for both sides. So I get 2 sine theta equal 1. Divide both sides by 2. By 2, I get sine theta equal 1/2. Sine theta equal 1/2. Now you go back to the same example here, you use the same steps to find the value. Example, go back to the previous example. So theta equal, like this example, pi over 6 plus 2 by k, pi over 6 plus 2 by k, and the second one is 5 pi over 6. 5 pi over 6 plus 2 pi k. Okay, like for this example, the equation will be like, is not smooth, sine equal 1/2. You have to fix it, then you have to solve it. Any question here? Is it clear? This is the last example in this section. So now for the other examples, we don't need it. It's not required. So now let's go to the last section for this material is 10.8 system of nonlinear equation. Before we go to the new chapter, everything is fine here? Any question? Okay. So now 10.8 system of nonlinear equation. Okay. So what is the meaning of nonlinear? Non-linear. Any one can explain what is the meaning of nonlinear equation? Yes, parabola. What else? This is true. Parabola is
Asymptotic graphs.
asymptotic graphs.
Like asymptotes, like roots or whatever.
This is no, I can't say this is true.
Okay.
But what about exponent greater than 1? Like I know the linear function is something like that, ax plus b. The exponent for linear function is 1. But anything is not 1, like 2 and more, will be nonlinear. This is linear because the exponent has 1. But anything has exponent 2, 3, 4, 5 is not linear. So this is solving a nonlinear something. Oh, so like equation like this. For example, x to the power 3 or x to the power 2 plus y squared equal 100 and 3x minus y equal 10. So system means set of equations. So this is like system, have equation 1, equation 2. So this is called system. So now we're going to learn how to solve this system, how we can find the value for x and the value for y. So the first method is called the substitution method. So substitution method, something here, substitution method. So this method is the number 1. It has steps. The steps is like this. First things we have to solve in terms of y. So this is the steps. Solve for one variable, substitute, back again and substitute. Okay, let's solve this system by using the substitution method. So this is my first equation, equation number 1, and this is my equation number 2. Solve for one variable. So you go to the equation number 2 because it's easier, it's a linear, and I'm going to solve it for y equal. So this is mean like equation number 2 is 3x minus y equal 10. I'm going to solve it in terms of y, means I make it y equal something. This is what I mean of solve for one variable. So here I have to move the y minus y to this side. So moving this to this side and also moving the 10 to this side. So to move the y to this side, I have to add y. So I get 3x equal y. And to move this 10 to this side, I have to subtract 10. So negative 10. So y equal my equation 3x minus 10. This is the first step. So now I get another equation, call it equation number 3. Second step, substitute. So I'm going to substitute equation number 3 inside equation number 1. Okay. So step 2, substitute plug this one inside the first one. So I get x squared plus y squared equal 100. And the equation y equal 3x minus 10. So here I'm going to plug y equal 3x minus 10. So I get now x squared plus 3x minus 10, everything squared, equal 100. So here, by using the properties, says a plus b square is equal to the first one square plus 2ab plus b square. So the same things here. I get x squared plus the first one square is 9x squared minus 2 times the first one 3x times the second one 10 plus second one square 100 equal 100. Okay, simplify. So I get here x squared plus 9x squared is 10x squared minus 2 times 3 is 6 times 10 is 60. 60x plus 100 equal 100. The 100 with the 100, they cancel each other. This with this. So now I get 10x squared minus 60x equals 0. I need to find the value for x. I have to solve x. So what I have to do here? How can I find the value for x?
You can factor out
Factor.
x. Factor out 10x.
10x, exactly. So factor by 10x, I get here x minus 6 equals 0. Now I have to solve it. 10x equals 0 or x minus 6 equals 0. So 10x equals 0 or x minus 6 equals 0. So x equals 0 here or x equal at 6 for both sides 6. So for x equals 0, I have to find the value for y. For x equals 6, I have to find the value for y. So at x equals 0, the value for y just to plug the x inside any of this 1 or 2 or 3, whatever you want. So I'm going to use the 3. Plug here equals 0, so I get 3 times 0 is 0 minus 10. So by using y equal 3x minus 10, this equation. So plug the 0 inside the x, so I get y equal okay. So here I get the question, where did you get the 10x equals 0 and 6? Okay. Here. After I simplify everything, I get 10x squared minus 60x equals 0. I factor this one. So here factoring. Factor. I get 10x times this one equals 0. So by using chapter 1, I think, said if A times B equals 0, this is mean A equals 0 or B equals 0. So the same things, 10x times this things equals 0, 10x equals 0, or x minus 6 equals 0. So 10x equals 0 or this parenthesis equals 0. Okay, Martin?
Does that mean that the equations are equal at x equals 0 and x equals 6? Is that what we just figured out?
Yeah, I mean like this value equals 0, this is my A, or this parenthesis equals 0, this is my B. This means 10x equals 0, x equals 0, or x minus 6 equals 0, x equals 6. Yes is the solution. 6 is a solution for x. Yes, is a solution for the equation. So at x equals 0, I need to find the value for y by using equation number 3 here from the before. Equation number 3, this one. Or I can use number 1 or number 2, but 3 is the easiest one, the simplest one. So plug the 0 inside this formula, I get y equal 3 times 0 minus 10, and this is equal minus 10. And at x equals 6, the value for y by using the same things, using the same formula, is y equal 3 times 6 minus 10. 3 times 6, 18, minus 10 equal 8. The solutions is 0 and negative 10 and 6 and 8. Any question?
So sorry, so those are the values at which
This is the answer.
the graphs cross each other?
Yes.
Okay.
Yes. The graph cross each other at these two values. And this is the solution. If you plug this one inside the equation, they will give me 100. If you plug in the second one, they give me 10. The same things for the other value, 6 and 10, 6 and 8. If you plug it in this here, they give me 100. If you plug it here, you give me 10. So I have two solutions. Clear? Any question? So this method is called substitution method. Now the elimination method. So this is the substitution method. Step 1, step 2, and step 3. Step 3 is this one. Step 3. Back and substitute. Now the elimination method. So we have steps for the elimination. Here is the step for the elimination method. So the first step is adjust the coefficient, add the equations, back and substitute. So we're going to solve the same example. I mean like this one. Instead of the substitution method, I'm going to use the elimination method. So the example is the same. Is 3x squared plus 2y equal 26 and 5x. No, I'm going to use different example. Sorry. I can use the same example, but it's better to use a different one. Equal 3. So first step, I have to do adjustment for the coefficient. I mean like, so you start thinking which variable would you like to eliminate? Which variable would you like to cancel? The x or the y?
So isolate the y. It's easier.
Easier the y? Okay. So if I want to cancel the y, I have to do step. I have to multiply this by -2, and I have to multiply this by 7, positive. Why? Because 7 times 2 is 14. 2 minus 2 times 7 is minus 14. Because for the second step, adding the two equations, I will eliminate the y. So multiply all this equation by 7, multiply all this equation by -2. What I get here? 7 times 3 is 21. X squared. 7 times 2 is 14. Y. 7 times 26 is, what is 7 times 26? Is 182. Now for the second one, -2 times 5 is -10. X squared. -14. Y. -6. So this is step number 1. Step number 2. For step number 2, I have to add this equation and this equation. Equation number 1 and equation number 2. So what is the adding of these two equations? Negative here plus 14y, -14y, this will cancel each other. This is the important things. That's why it's called elimination. 21 minus 10. What is 21 minus 10?
11.
It's 11. 11 x squared. 182 minus 6 is 176. Okay. Now, divide both sides by 11. Divide this by 11, this by 11. I get now x squared equal, this is by 11 is equal 16. Take the square root. X equal positive, negative, square root of 16 equal positive, negative 4. So the first value x equal 4, the second value is x equal minus 4. Now back and substitute to find the value for x. Step 3. So x equal 4, negative 4. Okay, which one would you like to use? Substitute. Which equation? 1 or 2? So I'm going to use,
Let's use
yes.
one has smaller numbers.
Which one is the easiest?
One.
1, okay. So I'm going to use number 1 to plug the x values. So the equation is x squared 3x squared plus 2y equal 26. At x equal 4, plug it here. So y equal, so plug it the 4 here. So I get 3 times 4 squared is 16 plus 2y equal 26. 3 times 16 is 48 plus 2y equal 26. Subtract 24 from both sides. I get 28 2y equal 22 minus 22. Divide by 2, negative 11. So the y value is negative 11. Here for negative 4. So same steps, y equal. So again 3 times negative 4 squared here 4. So it's gonna be like the same steps for
It's just plus minus 4, right?
Yes.
Right, because doesn't it make no difference?
Yeah, the same things will not be like difference. But I'm going to show you the steps. That's why. So negative 4 to y equal 26, and the same steps like here, because negative 4 squared is 16, like times 16 plus 2y equal 26. So y equal the same things, negative 11. So the y here is negative 11. So the solution are 4 and negative 11 and negative 4 and negative 11. Any question? Any question? Is it clear? Okay. So this is called the elimination method. Now, the last method is calling the graphing method. So the graphing method So for this method here, we're not going to do it. Just I'm going to give you like the idea for this because we don't have to use it. The graphing method is just graph the two equations and find the intersection for these two equations. The point where the two function to where the two equations are intersect, this is the solution for the system. So here I can set by graphing and find the intersect point. It's not important to do the graphing. The most important is to know how to do the substitution and elimination. Any question? Is it clear? Okay, so I'm going to stop until here, and this is the last things in this material. So get ready for the quiz in the opposite.